Swarup, I'll hand over to you for the next session.
Thanks, Satish. Hello, everyone. My name is Swarup. And thanks, everyone, for making your time and joining this. And thanks, Satish, for giving me the opportunity to give a seminar. So just a few bits and pieces about me. I have 10 plus years of experience in application security, threat modeling, and code review. A little bit of code, coding too. And I have experience in cloud security also. I had CH and OSCP certifications, and I'm master's in information technology, chapter lead for OAS Bay Area chapter. So I have my details here if you want to connect or if you want more information about me. And so today topic from my side is building trust in your container supply chain. So before diving into the topic, just want to give a brief background. Seems there are so many attacks happened in supply chain world, and so so many known attacks such as SolarWinds attack and all those stuff, and which led the US government also to take some steps to prevent supply chain attacks. And they have government orders and all those things happened around this area. So I just thought of giving, taking supply chain security at multiple places. I have given few demos in OAS Bay Area and Pacific Hackers also. So when I was giving demos, I understand one thing: supply chain security is ever fresh. If I go and talk to a few people, so there is always something new about supply chain security. So that's what led my interest in this area basically. And the agenda looks like this for today. And what are the container supply chain challenges, and how to establish the trust in containers, and take you through what is a software bill of materials in the container world, and signing and verifying container images. So before directly jumping onto the supply chain world, so let's look into the container ecosystem, how it is and all those things. So what happens in the real world, as we are all working on the real-time applications, basically what we'll do as a developer, as a user, so he'll do some changes to the code, and they'll push the code into the Git repo, or it may be GitLab or GitHub, Bitbucket, whatever you name it. And so once during the build step, whatever the code available or whatever the dependencies available, and everything will be built into a container image. And this container image will be pushed to a container registry. So there are many container registries in place. So GitLab container registry, GitHub registry, JFrog, whatever you name it. And once, and it will be pulled from the registry, and by using the container orchestration tools like Kubernetes or Docker or what, and Google containers or AWS stuff. So you'll be deploying the code into the using container orchestration tools and all those things. So this is how it works. And it is a bit different than the regular old style deployments way. How it is different in the containerized world. Let's look into how it looks like when we look into so when we are creating the container image, how it looks at the back end. So if you look at the code at the high level, the first line tells, so from Ubuntu latest. So this is the base image, and you are taking that base image and you are running few layers on the base image. And this is an important point: when you take a container or container orchestration stuff, everything is a layer basically. So from Ubuntu latest is your base layer, and you're getting the base image, Ubuntu image. And if you understand this Ubuntu latest, so it tells, so pull the image or take the image with the latest tag on it. That is a problem for different another day. So why you can't use the latest, and why you have to use a specific tag when you're pulling the image. And so you're running your apt update, and you're creating an application directory, copying everything into the application directory, and making application directory as your work directory, and you're running Python pip. Like you're installing Python pip, and you are installing all the dependencies to requirement.txt, and then finally you're running your application. So everything is a layer here. This is the base layer, and installing Python pip is another layer, and installing requirements.txt is another layer. So you need to make sure you are secured from all these layers, or you're securing all these layers. You're securing all these layers with the tools available, or with the configurations, with the security configurations and all those things. So there might be vulnerabilities in the base image, in the base layer itself. So there might be many libraries which are pulled through your base image, and there are many vulnerabilities associated with the libraries basically. At the same time, there might be vulnerabilities with the Python pip library you're installing, and there might be vulnerabilities with the dependencies you are installing through requirements.txt. These are all combined into your, supply chain stuff basically. And let's look into each layer. So what is the issue, or what will be the vulnerabilities when we have an vulnerable base image? So for that, I'm taking Image Magic as an example. Basically, Image Magic is a library which is used to resize the images basically. And so it was a big vulnerability at the time. So there is a CVE also around it. When it was found. So what happens on the back end basically is now my app container. So this is my app interface, which is the UI basically, and this is my app container, which is having Image Magic library, and this is having a vulnerability. As an end user, I know this particular application is using Image Magic library to resize the images in the backend. So what I'll do, I'll just craft a malicious payload as part of an image, and I will try to upload that to the UI, through the UI. And once it is processed on the back end, so this malicious payload, if you carefully observe this malicious payload, what I'm doing is I'm trying to put a reversal in it and make the container to execute it. So once it is executed, I will definitely get the reversal, and I can do whatever we want basically. So now the problem lies in the vulnerable version of the Image Magic library. So what happened if I use a base image with an Image Magic library in it already, and if you are not aware of it, and how as an attacker I'll get the reversal. Let's put this theory stuff aside and do the practical stuff. One second. I'll bring this later. So let me know if it is visible for you. Perfect. Okay. So there is a base image which is vulnerable base image which is having Image Magic stuff. So that base image is this one. I'm just copying my commands to save time. So the image is Image Tragic. So I'm just pulling it to my Docker repo, and So what I'm doing is I'm just running that particular, there's a small application as part of that. I'm just running that. So when I run that application, so which is, it is running in my local host. Let me pull my browser. Yep. So if I go to localhost and 8080 public, so if you can see, at the UI allow their upload an image to convert it to a Twitter ideal photo, which is this size, and as I shown you earlier, so I can quickly upload an image which is having a reversal in it. So I have that already, and so before uploading that image, let me quickly run netcat command to handle the session, which the shell basically. So now this is where I'm trying to catch the reversal, which is coming through when I upload the image. So 1 second, let me do this for to be very easy. If you, yeah. So when I choose the image and click on resize, but this time I should get my reversal. So if you see this is processing, if I run any command, I have already got the reversal on it. So just to make sure, I mean, like we are getting every time we run this. So I'll just show what is available as part of uploads. So I tried it 2 times today, and there are 2 images. And let's come out of it, and let's run it again. Actually, so choose file. Sorry, let me run the netcat and choose file. But this time I should get it. So now again, let's do. I have 3. So this is where if your base image is having any vulnerability, and if you're not aware of that, you are simply using that as a base image and running something on top of it. So you will be vulnerable to so many things basically. So now what we have to do here, so to avoid these type of things. So one thing you have to do is your base image should be coming from any official repos. Basically, Docker has its own official repo. So download the base image or take the base image from official repo, or take the base image from your private repos. So where you have a JFrag repository, and all the base image goes there, is the base image or the images pushed by you basically, or pushed by the organization. That is there are few ways of doing that. So either pull the official repo base image, or use the base image which are built by you. So this is one problem. So where you need to make sure your base image is secure. And after that, what will happen is you need to establish the trust with respect to the supply chain you are getting. And if you're aware of the SALSA framework, basically, you can understand what each level brings into your environment. So now same stuff. So as a developer, as user, I'll push the code to my code repository. So which is having, I mean, like my base image, my dependencies, my source code, everything will be built into a container image, and that container image will be pushed to a registry. At the same time, I will be using the image to deploy everything. Now we have discussed about the base image issue, which is completely different. Now let's discuss about the supply chain stuff. What are the levels of SALSA basically? So SALSA level 0 gives no guarantee. So SALSA level 0 tells no, you are not maintaining your security posture as part of your deployment with respect to supply chain. What is SALSA level 1? So which gives unsigned provenance basically. So now this is a simple policy. You have to make sure what your application is using to make sure you are securing them basically. So you need to make sure this is the metadata around my application, then only you can secure it. Without having, the metadata around your application, you cannot do anything basically. So SALSA level 1 tells that basically. So when you are using something, you need to make sure you have a list of all the things. Let's say you are using this library, you are using this base image, and you are using these dependencies and all those stuff. You need to make sure you have a list of them. So what helps you to get the list, or what helps you to successfully fulfill your SALSA level 1 is SBOM, software bill of materials. So what is SBOM with respect in the containerized world? It is a nested inventory with all of ingredients that makes up, your software component basically. And your SBOM tells you many things basically. What is the dependency name? Who is the supplier of the dependency? Whether it is a licensed dependency or not? Whether it's compliant with the security or not? And all those things. So you have to make sure you will have a list of all the all the dependencies you're using, which is making up your software component. So let's understand more about it basically. So there are few SBOM elements. So who is the author of a dependency? Who is the supplier of the dependency? What's the component name around it? And what is the version you are using? And if there is any hash for the dependency, use the hash. If there is any unique identifier for that, and what is the relationship? So this is the technical way of understanding, right? So let's come out of the technical way of understanding and understand the non-technical way of understanding your SBOM basically. So when you go to a supermarket and you'll find, you'll buy a product. So when you're buying a product in the modern world, what people are doing, people will be looking at the nutrition facts around it basically in a product. So how much cholesterol is there? How much sugars are there? What are the soluble sugars? What are non-soluble sugars are there? What are the vitamins in the product? And what is the fat? What is the saturated fat? What are the trans-saturated fat, trans fat, and all those things. So if you take a product, this is the SBOM for the product basically. So which is software bill of materials for a product you're buying from a supermarket. But at the same time, you apply that technology to your software packaging, so which is similar to that. So I'm using this library, I'm using this dependency version is this, and dependency has all these vulnerabilities and all those things. So you need to maintain that to make sure you have proper trust established in the your development pipeline. So the first steps of SALSA tells you need to maintain a list, documentation of the build process. So that tells you have all these ingredients in your software build. So now what is step 2? Okay, now you have the list of stuff. How you are making sure the list of stuff is what you are expecting. Oh, sorry, before going to that, so once you have SBOM, so SBOM, there are many formats: software package data exchange format, software identification tagging, and OSCP has its own format, Cyclone DX. But all those formats rotates around or revolves around the elements basically. Now you have the list of ingredients for your software packaging. You need to make sure if there are any vulnerabilities in the list of ingredients, so which is my supply chain. So the supply chain I'm using as part of my software packaging is having any vulnerabilities. So there are tools around it. Shift is one which will help you to generate software bill of materials. And at the same time, Gripe is a vulnerability scanner. So based upon the outcome of it will find out the vulnerabilities within your software bill of materials. So this is, let's do that on the image magic base image to see what it is producing for us. Um, so I'll be using the same image to generate my SBOM using Shift tool. I have installed Shift already in my machine. So when you run Shift on the same image project, it'll take some time. It will generate the SBOM. It will list out all the supply chain elements in it and create a JSON. Let it finish. And meanwhile, it is running. Any questions?
So it's very important to understand, I think, container security in order to cater to cloud security, right? Swarup?
Yep. So it tells there are 749 packages in this image basically. So it has created as bomb.json. So it will be a big file basically. If you look into it, there are so much stuff it will tell. So let's take one particular thing, if I can explain in the best way. Mm, maybe let me run gripe so that you'll get good details actually. So what gripe will do is gripe will find out all the vulnerabilities with respect to the dependencies find in SBOM basically. So gripe will not take much time. Yes. So, so if you look at the gripe output basically, cat .json. So again, it is a big file. Same stuff. You will be getting more details here. So it is telling. So the vulnerability is this, and what is the description? Regular expression denial of service in npm user validate basically. So npm has a library user validate, and there is a denial of service in that. And at the same time, so there are so many vulnerabilities in the libraries used. So I am not interested in all those stuff. I just want to see if gripe is able to find out the remote code execution vulnerability in the SBOM. So when I run gripe for specific CVE, it is giving me this. So gripe is telling image magic has this vulnerability, which is high severity, and this is the CVE. And at the same time, what are all the other components of image magic is having library, image magic core, dev is having the same vulnerability. So gripe is able to tell me, so your base image is having this particular vulnerability. So this is where these things will be helpful. So if you are not doing all these steps as part of your pipeline, then you are at risk basically. That's what I'm trying to tell here. So now what will happen? So SALSA level 1 tells, you need to make sure how to build your SBOM and you have to find out the vulnerabilities in the libraries of your SBOM basically. What, okay, now so in the pipeline, I created SBOM, and at the same time, I have found out the list of vulnerabilities and I have fixed them. So this particular step is clear. And what is SALSA 2 basically? SALSA step 2. It is telling tamper resistance of the build service basically. What happens here is, okay, now this is the base image you are taking from your either public, either your private repo or, for example, JFrag repo. What makes sure this particular image is not tampered? So that is the example. So let's take an example of Trojanized image here. So let's take a public container registry. And what happens usually is, as it is a public container registry, if there is an image called ABC, multiple people will be working on it and they will be pushing multiple times in a day. So, and what you always do, this is what I told you basically. So using latest tag is a problem for another day. There is a bigger conversation basically. So as usual, I'll go and pull the latest image of it, and somebody has put a reversal in it basically. When I use that, I am prone to all those. Like I am usually risky, and my all information in that application is at the risk. So this is a Trojanized image. How to stop it basically? So if it is not a public what we called a container registry, let's take JFrag stuff. So the attack vector is a bit different here compared to public container registry. So what happens if your JFrag repository credentials are leaked somewhere and someone got hold of them and they pushed a Trojanized image into your JFrag registry? So you always feel and you are in a comfortable zone of, okay, this is my private registry and no one will be doing anything. So what happens if the credentials are leaked somewhere, and if someone is able to push some Trojanized image there, you will be downloading the image and you will be using that. So which is, you will be not knowing that, but which is very, very dangerous stuff. So what SALSA step or level 2 tells you, you have to make sure a signed provenance is in place. What is signed provenance is nothing but the base image, which you are pushing, should be signed by your private key basically. So in a basically in an organization, so there will be multiple people who will be pushing the images and will be pulling the images basically. But you need to make sure who are pushing the images should use a private key, and the private key should be somewhere in the vault. And who are pulling the images should be verifying those images with a public key basically. So what in this case, even though if some issue happened, like your credentials for JFrag registry has leaked somewhere, someone pushed a content, right? Like Trojanized image. What happens if I'm trying to use that image, my verification fails. So if I'm using the same public image to verify the image, it fails. It tells, no, this particular image is not signed with the private key intended, so you cannot use it. So that is where SALSA step level 2 come into picture and provide you some level of assurance. Even though something happens, you have some level of assurance, where we always call it defense in depth basically. Signing images is one important step to avoid some vulnerabilities like Trojanization, all those stuff. So again, put the technical side of it aside, and let's try to discuss it in a non-technical way. So this signing images is nothing but signing an agreement basically. So this is an older approach. So if you are buying a property, so the buyer and seller comes and they will sign, and buyer will have his own record copy of the agreement, and seller will have his own copy of the agreement. So if someone changes something in the agreement, what happens? So he can double check. If buyer changes something, he can double check with seller's copy. So you have changed something. It is not there in the copy which is provided by you, and we both are signed in it. So which is nothing but the same concept has been applied here. Signing image is nothing but, so whenever I'm pushing the image to so what will happen? I create a public private key of public private key pair, and I will be using the private key to sign the image while pushing. And if someone is want to use the image, and they will use the same public key created by me, and to verify the image. So if something changed as part of that, so my public key verification will fail, and it tells no, something has been changed, you cannot use. Basically it is contaminated basically. So that where SALSA step 2 level 2 will help you in maintaining the authenticity basically, or integrity. I can say integrity. So there is also step 3 and step 4, which is more advanced steps. So what SALSA step 3 tells, so extra resistance to specific threats basically. So as a supplier, so let's say I am the owner of a specific library. As a supplier, I need to confidently tell I am taking care of all these steps. And even though if you're using this, you should not be prone to any vulnerabilities. That is SALSA step 3. And SALSA step 4 is the highest level of confidence and trust. So there is a 2-party review where 2 people or 2 additional organizations has to trust or tell this particular library or this particular component is safe to use, and security builds. So someone who is the supplier has to put a document around the build process. So this is my build process, and I have taken all these steps to make sure my component is secure. So that is also step 4. This is how we can maintain the security in supply chain. So putting all these things together, there are a few recommendations basically. So only pull the containers from trusted sources, example, your private repos or docker.io official images. And it is good to use specific tags rather than using always latest. So when it is public maintained repo, I mean, use always specific tags. So one good example I can give, if you use, let's say, take log4j into as an example. So you tell your organization, so the secure version of log4j is in this image with this tag. And someone comes and changes the log4j into an insecure version and give it as a latest tag. So if you pull a latest tag, you'll be getting the insecure version of log4j at the same time. So the maintenance of specific tags is always important. At the same time, generate SBOM and monitor for vulnerabilities associated with it. And enable container scanning in your CI/CD pipeline and update the containers as frequently as possible. And sign and verify the images, sign and verify the SBOM. Yeah, I forgot something. You can also sign your SBOM also in the same fashion you are signing the images, and run your containers as the least privileged user. And the last but not the least one is like prefer minimum or distroless base images, only install the dependencies you need. So don't overweigh your images, and that overweight will carry the vulnerabilities with those also. So use whatever is minimal and whatever the dependencies you need. That's it. And please ask if there are any questions. And I hope it is useful.
Yeah, definitely useful, Swarup. Thank you so much. It was a wonderful session with with the all with the way to hack. It's really good to see, and it is very important to have complete knowledge of container security if you want to build your profile in cloud security, because cloud security, what you'll be finding is all about the containers, how what kind of vulnerability it could cause. So it is very important to understand this piece.
Thanks, Suresh.
Thank you. Thanks to you. It's an awesome presentation. Yeah, thank you so much for the feedback. Yeah, we'll try to incorporate it in the next session.
Thank you.
Thanks everyone. Bye.